And here we are with the 3-6 assignment. So, in our 3-6 assignment, our first question is to find the amount A accumulated after investing a principal P for T years at an interest rate of R compounded annually. So if we go to our formula sheet, we've got the formula for interest compounded annually, which is going to be P1 plus R to the T. So as you can see, they're giving you each of these pieces already. The only difference, of course, is that 7% is actually going to have to be written as its decimal equivalent of 0.07. So if we plug in each of those pieces, we can find A by plugging in a P of 1500, an R, 1 plus an R of 0.07, and then into a T of 6. So in order to solve this, you're going to do what's in the parentheses first, so 1 plus 0.07. Then you're going to bring that to the 6th power and then multiply by 1500. And so our amount after a 6-year investment is $2,251, and since we're doing money, 10 cents. Alright, next one. We need to find the amount accumulated after investing a principal P for T years at an interest rate, and this is K times per year. So notice that this is going to be what they call quarterly. So that means that we are going to use the interest compounded K times per year formula, which is A equals P1 plus R over K to the KT. Alright, and so then we get to plug in each of those pieces. So we're trying to find A. Our P is 1500, 1 plus an R, which is 0.07 again, K, which is 4 for quarterly, and then to the 4 times a T of 5. So in order to solve this one, we again start with the parentheses, so 0.07 divided by 4, add that with a 1, bring that to the power of 20, 4 times 5, and then times 1500. And so this investment, after 5 years, is going to result in 2122.17 for money. It's a dollar sign. Okay. Then we need to find the amount A accumulated after investing a principal P for T years at an interest rate of R compounded continuously. So compounded continuously means that we're going to use the interest compounded continuously equation, which is PE to the RT. Again, our R needs to be our decimal equivalent of 5.4%, so 0.054. Filling in our equation, we have a P of 1,250, and then E to the 0.054, and then a T of 6. So evaluating this, we multiply our exponent, so 0.054 times 6, then we bring E to that decimal of 0.324, and then multiply by 1250. And so we have a result of $1,728.31. Alright, moving on. We're going to find the future value. So they already tell you, we don't have to necessarily identify, but we're finding the future value accumulated in an annuity after investing periodic payments R for T years at an annual interest rate of 0.07 as its decimal, with payments made and interest credited K times per year, so in this case, quarterly again. So we're using our future value equation, and so that means that our future value is going to equal our R, which they said was 500. That's going to be multiplied times 1 plus our R, which is 6, our little r, our rate, that's a T. Our rate is 0.07 over K, which is 4. Alright, and then bring that to the K times T, so 4 times a T of 6, That number will then subtract 1 and be divided by 0.07 over 4. So again, order of operations, definitely going to go inside these innermost parentheses there. So 1 plus the fraction of 0.07 over 4. That's going to be brought to the 4 times 6. To that 1.51, we'll subtract a 1. Then we'll divide that by the fraction of 0.07 over 4. And then multiply the 29.51 that we would get for this value times 500. And so apparently your investment is now $14,755.51. But of course that's at $500 per month. Yeah, for 6 years. So, all right. But it actually says periodic payments. Okay. So, either way, in number 17, we're looking for finding the present value. So again, they mention the formula we're going to use. So present value with an R of 4.7. So remember decimal is 0.047. Your R is 815.37. And then we're going to do 1 minus the fraction of 1 plus R as your percent, so 0.047 over K, because it's saying 12 times per year, to the negative K, which is going to be 12, times our T, which is 5. And then that fraction divisible by 0.047, the rate over 12, the number of times it's taken per year. So innermost fraction there leaves us with 1 plus 0.047 divided by 12. That is going to be then raised to the negative 60 for 12 times 5. Then 1 minus that number is what we're looking for, and it being divided by 0.047 over 12. So for this piece, we get about, apparently I got an eraser, 53.38 for that value, which will then multiply by 815.37. And so we get 43,523.31. Alright, so moving on, we have the periodic payment R, so apparently we don't know what that is, because we want to find it with a present value. So again, they already mentioned what our formula is going to be, of 18,000. And so we don't know what R is, but we do have a rate of 0.054, the fact that it's going to go for 6 years and 12 times per year. So for the present value equation, that means we'll do 1 minus 1 plus the R, which was 0.054, over K, which is going to be 12, to the negative 12 times 6. And then that's all over 0.054 over 12. So notice that we are solving for R, so once we get the value of this piece here, we'll just divide it to both sides. So innermost parentheses here means that we'll do 1 plus 0.054 over 12. That value is going to be raised to the negative 12 times 6. 1 minus that value. Divide that value by the fraction of 0.054 over 12, and so our value here is 61.38. So that value is going to be divided to both sides, and so 18,000 divided by that 61 value means that our R, or our payment for monthly, is going to be $293.24 in order to get to that $18,000. Alright, next question. If John invests $23,300 in a savings account with a 9% interest rate, compounded quarterly, how long will it take until John's account has a balance of $4,150? So, biggest thing here is that we're seeing that it's saying compounded quarterly, and so that means that we're going to use that formula of P1 plus R over K, because we have a K value, to the KT. Alright. So plugging in what we have, he's investing the initial value of $2,300. He wants the ending result to be $4,150. His rate is 9%, so 0.09. His K is quarterly, which means 4, and then we'll bring that to the 4 times T. And then, of course, we're solving for T. So, to solve this, we'll divide by that multiplier of 2300. So 4150 divided by 2300 leaves us with 1.8043. I'm going to get this as a decimal while we're at it. So 1 plus the fraction of 0.09 divided by 4 leaves us with 1.0225, and that's to the 4t. So the reason I did that is now that we can write it in log form, because it's in exponential form. So we'll have a log base 1.0225 of 1.8043, and that's going to equal 4t. So I ran out of room on there. So we can evaluate that. This piece here is a decimal. So log base 1.0225 of 1.8043 is going to be 26.52, and then that is going to equal 4t, and so we divide by our 4. And we find out that it's going to take 6.63 years. Alright. So the next one is giving you interest rate compounded daily, and so again we're going to use the same equation as the previous, so the compounded K times per year. So it's going to be P of 1 plus R over K to the KT. Alright. So K is going to be 365. We also have A. Oh no, sorry, this is our investment, so P, because who doesn't just have 22,000 sitting around? And then our A value is going to be this 36, because that's what they want it to get to in 5 years, so that's going to be our T. Okay, so filling this in, A is going to be 36500. Our P is going to be 22,000. And then that's going to be multiplied by 1 plus our rate. Oh, we don't know the rate. What rate do we want? Aha, so we're shopping for our rate. Over 365. And then raised to the KT. So let's see, K was 365 and T was 5. Okay. So that's a lot. Let's see. First thing we're going to do is take out that multiplier. So divide by the 22,000. So we get 36500 divided by 22,000, which makes 1.6591. And then that's going to have 1 plus R over 365 to the 365 times 5, so to the 1,825. So we're in exponential form as we had in the previous problem, so we're going to write it in log format. So we have log base, oh that's a gross base, 1 plus r over 365 of, let me think of a different way of doing this. Alright, well, let's continue. So 1.6591 equals 1825. Okay, so the way that we're going to write this is with our change of base, so that we have something that we can kind of maneuver around. So change of base means that it's actually log base 10, or whatever base you want, of the piece inside of the parentheses, so not the base, so 6591 over log of this thing equals 1825. For lack of a better way of doing this, I'm going to then flip the fractions, so it's actually 1 over 1825 equal to log of 1 plus r over 365 over log of 1.6591, which means that we can multiply each side by log of 1.6591. So again, multiplying by that base means that this is multiplied by log of 1.6591, and this is also multiplied by log of 1.6591, which then takes care of the logs. And then this right side becomes log of 1.6591. Forgot a 5 in there apparently. Divided by 1825. Oh, that's tiny. So that's 0.12312. Alright, and then log of 1 plus r over 365. So to stop this, we're going to take a 10 to the, which means it's going to cancel those 10s in the logs, and so 10 to this piece leaves us with 1.00028, and then 1 plus r over 365. To solve, we'll subtract a 1, and so we're saying what divided by 365 makes 0.00028, and so we'll multiply both sides by 365. I swear we're getting there. And we get an r of sorry, my calculator gave me scientific notation and I got a little confused. Okay, so times 365 is going to be a rate of 1.01269, blah, blah, blah. So that means that as a rate, we're looking for a percent of 2 decimal places, so 10.12, well, 13%. So that's the percentage that we need in order to get our investment of $22,000 to be $36,500. That was icky. If you found another way, please let us know. Okay. Determine how much time is required for an investment to double in value. Okay. If interest is earned at the rate of 5.75% compounded quarterly. So again, we're going to have to use our compounded k times per year formula with a k of 4 because of the quarterly. Alright, so k is 4, our r is the decimal equivalent, so 0.575. And then notice that it's just saying our investment is doubling. So technically, if we had $50 as the initial payment and $100, the math would say that we would divide by that 50 and get 2. So it doesn't really matter as long as doubled is happening. So 1 plus r over k to the kt. If you don't like that, then just pick a number, double it, and put it in for A. But basically I started with a P of 50, sort of, and an A of 100, which would have doubled it. This is technically a 1 here for your P now, and so doubling it would make 2, if you want to look at it that way. Alright, so either way, we are going to put in our R now. So 1 plus R, which is 0.0575 over quarterly, so 4 to the 4 times T. Because we're asking how long will it take. So let's go ahead and make this decimal here. So 0.0575 divided by 4 plus 1 makes this 2 equal to 1.014375. Don't know why I did the whole thing. To the 4t. So to solve, since we have an exponent, let's take logs. Why not switch it up? We'll take natural log. We'll rewrite, in log form. So we can't do natural log. Log base 1.014375 of 2 is supposed to equal 4t. So this left side becomes a decimal. And that decimal is 48.5647. And so to solve, we divide by 4. And we get 12.14. And we are talking about T, so probably years. For it to double. Okay. So we're going to complete the table in this next one about continuous compounding. So continuous compounding is going to be our formula of PE to the RT. And so your initial investment is going to be P. Your annual percentage yield is going to be your R. And then now we're looking for our time to double, meaning the double of 12,500, which is 25,000, and then when T equals 15 as well. Also don't be confused with annual percentage rate and then annual percentage yield to work this backwards or anything. So let's see, filling in for the first piece, which is to double, we're going to end up with 25000 and 2500 as your P, and then E to the 0.09 for 9%, and then we're trying to find T. So to rewrite this, or to solve this, we get dividing by 12500, which of course is going to result in 2. Then let's see, since we have a base of E, we're going to rewrite this in log format, but natural log format. So that means we have natural log of 2 is going to equal 0.09t. So natural log of 2 happens to be 0.6931. And so if we divide by that multiplier of 0.09, we end with a t, or a time frame, of 7.7 years. Alright, the next one wants the amount in 15 years. So over here, we're just going to solve. If we take A, we don't know, we're trying to find it, 12500, and multiply it by E raised to the R, which was 0.09, and then T now of 15. So E to this exponent of 0.09 times 15, and then that value times 12500, is going to make your A amount after the investment of $48,217, which makes sense because after 7 years it doubled, so of course after a much longer time of 15 years, hopefully it's going to do more than just double there. Alright, so this next one here, again, this idea of time to double does not matter what your initial amount is. So for instance, we could do 50 and then the amount after the double is 100. But remember that just means that the P and the A are kind of moot and we can just put a 2. So we're compounding in periods of quarterly, so that means that we are going to have to use the equation of A equals P1 plus R over K to the KT. Or, let's see, we already did A and P, so we need 1 plus our rate, which is 0.04, over K, which was quarterly, and then that's going to be 4 times T, because we're trying to solve for T. So we need this evaluated as its decimals, so we can eventually rewrite it. So 0.04 divided by 4 plus 1 is a 1.01. So rewriting in log format, that means that we're going to have log base 1.01 of 2 equals 4t. And so that evaluated as a decimal gets us 69.6607. And then of course we solve by dividing by that multiplier. And so we end up with a time frame of 17.42 years. People got time on their hands here. Okay. Alright, so the next one is your APY. We haven't done a lot of those problems, but we do have a formula for that. Our APY, our annual percentage yield, is going to be 1 plus R over K to the K minus 1. So it's kind of a piece of that kind of present value idea. So, let's see, our R is going to be 0.06, and the 3,000 is going to help us at the end when it asks us for the value of the investment. Alright, so we're going to do 1 plus compounded quarterly, so 0.06 over 4 to the K, which is 4. And so simplifying this, we will do the inner part here. So 0.06 divided by 4 plus 1 raised to the 4 means that we have 136 minus 1. And so if we subtract 1, we get 0.0614. So this is your rate, but of course it's as a decimal, so it is 6.14%. And 6.14%, they don't necessarily ask that. As you see in the answer key, it just asks for the percent. Can be multiplied, actually in this format, times 3,000 in order to see after a year how much you would get. Let's see, 1.06136. So it would end up being at $184.08, included with that 3,000. So, all right, they didn't ask that. I just went forward. Okay. So we're going to start with problem 45 on our next video, or part 2.